An ascending series of numbers satisfy the following conditions. When divided by 3, 4, 5 or 6, the number leaves a remainder of 2. A number when divided by 3, 4, 5 or 6, the numbers leaves a remainder of 2. All the numbers is leaving a remainder 2. When divided by 11, the numbers leaves no remainder. The sixth number in this series will be. Now we need to find out all the number which is satisfying this condition. So the smallest number which leaves the same remainder is the remainder itself. The smallest such number is the remainder itself, 2. 2 when divided by 3 will leave remainder 2. 2 when divided by 4 will leave remainder 2. The next number you will get it after adding the LCM. Normally in books, this number is giving as the smallest number. This is not the smallest number. This is the second smallest number. That is the next number. The smallest number is 2. So LCM is 6 into 5 into 2, 30. 6 into 5 into 2, 60. So I'll add some multiple of 60, and after adding 2, this number will satisfy this condition. All the number of this series will satisfy. 62 will satisfy, 122 will satisfy, and so on. But this number should be divided by 11. So this number should be a multiple of 11. We are looking for that particular number. So find the value of n such that we get an integer value. So if I put it 1, 62, no, it will not be an integer. If I put it 2, 122, it will not be an integer. If I put it 3, 182, again not an integer. But if I put it 4, I'll get an integral value. So the smallest number which is satisfying this condition, it's 242. So 242 is the smallest number which is divisible by 11 also. And once you get the smallest number, we need to find the sixth such number. That is the smallest number. That is the first such number. It's 242. Can you tell me the second such number? Second such number you will get it after adding the LCM of all the numbers 3, 4, 5, 6 and 11. That is the second such number. So what is the LCM of? You have already find the LCM of these number which is 60. So take the LCM of 60 and 11 which is 660. So add 660 in these numbers to get your desired number. So if you want to get the sixth such number, I'll get 660 5 times into 42. That is my sixth number. So 3300, 35, 42 will be my sixth such number straight away. That is my answer. So once you get the smallest number, that is 242, the next number will be after adding the LCM of all the numbers. So what is the LCM of all the number? LCM of these numbers we have already got it 60, 60 and 11 का LCM 660. So add करते जाओ 660 number आते जाएंगे सारे. So smallest number, second smallest number, third smallest number. We need the sixth smallest number. So add 5 times. Done. Come to the next one. Let's say the 3-digit number has digits in strictly descending order. Strictly descending order means A is greater than B, B is greater than C. And divisible by 10. Number will be divisible by 10 if this digit is 0. So C is 0. By changing the places of the digits, a new 3-digit number is constructed in such a way that the new number is also divisible by 10. So if new number is divisible by 10 and again it is a 3-digit number, so obviously this digit cannot be 0, because if this digit is 0 and this digit is 0, and if I interchange these two digits, number is in descending order, so these two digits cannot be same. And number is still divisible by 10, so we have not changed the place of this number, we have just changed the place of these two numbers. So now new number becomes BAC. After changing the digits of these two places, number is still a multiple of 10. The difference between the original number and the new number is divisible by 40. Now, what is the original number? Original number is 100A plus 10B plus C. And what is the new number? New number is 100B plus 10A plus C. The difference between the original number and the new number is multiple of 40. Which number is large number? This number or this number? A is greater than B, na? Digits are in descending order. So if A is greater than B, this number has to be more than this number. So if I subtract this number from this number, I'll get 90A minus 90B. That number should be multiple of 40. How many numbers will satisfy this condition? Now if this number is a multiple of 40, so A minus B definitely should be 4. Then only it will become multiple of 40, 360. No other number will satisfy 19 to 2 and one more possibility 19 to 8. That is 720. So we get to know that A minus B can be 4 or A minus B can be 8. Two possibility. How many numbers? 9 minus 5, 8 minus 4, 7 minus 3, 6 minus 2, 5 minus 1. I cannot take 0 here. 4 minus 0 I cannot take, otherwise it will be a 2-digit number. So 5 such number here and only one number here. I cannot take 0 again. So how many such numbers? There are 6 such numbers. So there is basically based on digits and digits reverse based question. We normally do it in simple equation. I have included this number in the numbers part. It's kind of numbers based question. So 6 such number. Go to the next one. Again a base system. As you can see, there are plenty of questions which are based on base system. Two numbers 2061 that is in B base, 601 also in B base. The sum of these two numbers in decimal system is 432. So if you simplify, this comes out to be 2b cube plus 6b plus 1. And if you simplify, this comes out to be 6b square plus 1. And sum of these two numbers is given as 432. So 2b cube plus 6b square plus 6b plus 2 should be 432. Or I can say b cube plus 3b square plus 3b plus 1, that should be 216. If you can notice, this is nothing, it is b plus 1 whole cube. B cube plus 1 plus 3b square plus 3b1 square. That is 216. That is 6 cube. So b plus 1 is 6. So b comes out to be 5 base. If b is 5 base, we need to find out the value of this number 1010 in decimal. So what is the answer? Answer is 1 into 5 cube. That is 0. So 1 into 5. 125 plus 5. The answer comes out to be 130. Okay, simple. But actually this question has a technical problem. This question is actually wrong technically. Why? Because if you are taking base as 5, if you're taking base as 5, you cannot write digit 6. But Z actually made a mistake while making this question. They did not think that this question is technically wrong, because if you're taking base as 5, you cannot write 6 here. Logic is correct, but actually mathematically it is wrong. Okay, answer is correct. Answer is 130. I hope you thought of also, okay, how come the base be 5 if the digit is written 6? Your doubt is genuine, but Z has made this mistake while making this question. Do not worry. Okay, come to the next one. Two positive integer a and b. If a plus b raised to power a plus b is divisible by 500, then the least possible value of a into b is, that should be multiple of 500. Two positive integers. Now two positive integers, the sum of two positive integers can be a multiple of 500 only when the sum is at least 10. The sum is at least 10, then only the 10 raised to power 10 can be multiple of 500. Now, can you thought of any other number in which the number is multiple of 500? Small number. 9 raised to power 9, obviously not. 8 raised to power 8. It is not possible. The digit should be at least 0. Then only it will be a multiple of 500. So that is the smallest number that will satisfy this condition. So what we need to find out? Least possible value of A into B. A plus B is 10. And if sum is constant, we know how to maximize the product. Maximum product will be when both the numbers are equal. But here we have to minimize. The product will be minimum when both the numbers are as far as possible. So I'll take one number as 1 and other number as 9. So minimum possible value is 9. The maximum value possible is 25. But we need to find the minimum. So answer is 9. That is the answer. Easy question.